Hey guys, good afternoon. These are your notes for 11-2, solving linear systems by substitution. Okay, when we do this, it says you can use substitution to solve a system of equations if one of the equations is already solved for a variable. So you can see in this system, we have y equals x plus 2 and 3x plus y equals 10. So it is actually already solved for y. If that's not done, you're going to rewrite one of the two equations so that it is solved for a variable. And I'm going to go ahead and skip this example, and I'm going to go down to the 4 at the bottom. And the same thing's going to apply on number 1. Number 1, they're actually both solved for a variable, which is y. So what you're going to do is take y equals in the first equation and plug it in for y in the second equation. Zoom in a little here. Okay. So our new equation will be x plus 2 equals 2x minus 5. From here, we're going to solve it just like a normal equation. So we're going to subtract x from both sides. So I have 2 equals x minus 5. I'm going to add add 5. X equals 7. Once I have one of the answers, I'm going to plug it back into the one that was solved. So I say y equals 7 plus 2. So y equals 9. And my answer to this system is the ordered pair 7, 9. On number 2, both of the equations are solved for x. So I'm going to take what x equals in the first equation and plug it in for x in the second. My new equation is y plus 10 equals 2y plus 3. And now I can solve this like normal. Subtract y. So 10 equals y plus 3. Then I'm going to subtract 3, and y equals 7. I'm going to take that answer and plug it back into the first equation. So I have x equals 7 plus 10, so x equals 17. So my answer is the ordered pair 17, 7. So you can see it doesn't make any difference if it's solved for x or y or which one we solve first. You get both answers. Okay, on number 3, neither one is solved for a variable. It doesn't matter which one you solve for a variable. My suggestion would be to do the easiest. So I'm going to solve number 1, or the first equation, for x because it has a coefficient of 1. So if I solve that for x, it'll be x equals y minus 3. Now I can take what x equals in the first equation and plug it in for the x in the second. So I end up with 2 times y minus 3 plus y equals 12. And I'm going to go ahead and solve for y. So I'm going to distribute my 2. So I have 2y minus 6 plus y equals 12. I need to combine like terms. So I have 3y minus 6 equals 12. Add 6. So 3y equals 18. And finally I'm going to divide by 3. So y equals 6. I'm going to take that and plug it into the equation that I solved for the variable. So x equals 6 minus 3. X equals 3. So my answer is the ordered pair 3, 6. Okay, 4 is a lot like that, but I'm going to solve the first equation for y because y has a coefficient of 1. So I end up with y equals x plus 8. So I'm going to take what y equals and plug it into the second equation. So I have 5x plus 2 times x plus 8 equals 9. Distribute my 2. So you get 5x plus 2x plus 16 equals 9. Combine my like terms. So 7x plus 16 equals 9. Subtract 16 from both sides. 7x equals negative 7. Divide by 7, and x equals negative 1. So I'm going to take the negative 1 and plug it into the equation that I solved for y. So y equals negative 1 plus 8. So y is 7. So my answer is negative 1, 7. Okay, and guys, that's all there is to it. I'm going to show you a couple extra problems on the other side. Okay, the first problem is on page 398. It's your turn, number 7. My system is negative 2x plus 14y equals negative 28, and x minus 7y equals 14. I'm going to solve the second equation for x because, again, x has a coefficient of 1. So when I do that, that equation becomes x equals 7y plus 14. And again, I'm going to take what x equals and plug it into the first equation for x. So when I rewrite, I have negative 2 times 7y plus 14 plus 14y equals negative 28. I need to distribute the negative 2. So I have negative 14y minus 28 plus 14y equals negative 28. Okay, I have to combine like terms. Negative 14y plus 14y is going to cancel out. So I end up with negative 28 equals negative 28, which is a true statement. So when we end up with a true statement, our answer is infinitely many solutions. And just a reminder from the previous lesson, if we were to graph that, that would look like two graphs on top of each other. Okay, the next one I want to show you is also on page 398. It's your turn, number 8. My system is negative 3x plus y equals 12 and 6x minus 2y equals 18. I'm going to solve the first equation for y. So I end up with y equals 3x plus 12. So I'll take that 3x plus 12, plug it into my second equation for y. So I have 6x minus 2 times 3x plus 12 equals 18. Okay, I'm going to distribute the negative 2. So 6x minus 6x minus 24 equals 18. I have like terms. 6x minus 6x is 0. So I'm left with negative 24 equals 18. And this is not true. And we know when we have a non-true statement, it is no solution. And again, a reminder from not yesterday, but the lesson previous, if you have no solution, its graph would look like parallel lines. Okay, my last example for you is from page 400. It's your turn, number 10. And it says, a boat travels at a rate of 18 kilometers per hour from its port. A second boat is 34 kilometers behind the first boat when it starts traveling in the same direction at a rate of 22 kilometers per hour to the same port. let D represent the distance the boats are from the port in kilometers, and T represent the amount of time in hours. The system of equations, D equals 18 plus 34, and D equals 18T plus 34, and D equals 22T, can be used to represent this situation. How many hours will it take for the second boat to catch up to the first boat? How far will both of the boats be from their port? Use the substitution method to solve this real-world application. So both of the equations are solved for a variable. So I'm going to take what D equals in the first equation and plug it into the second. So my new equation will be 18T plus 34 equals 22T. Okay, so I'm going to go ahead and solve. Let's subtract 18T from both sides. So 34 equals 4T, and divide by 4. So your time is 8.5 hours. And to get the distance, I'm going to take the hours and plug it, and I'm going to plug it into the second equation because it's less complicated. And we're going to say D, which stood for distance, equals 22 times 8.5, and that's going to give me a distance of 187 kilometers. Okay, your homework with this lesson is 11.2, page 400 to 401, 1 through 17 odd. Please make sure that you do check your answers in the back of the book and that you show all of your work for tonight. Thanks and have a good night.